Alright, what's going on everyone? Welcome back to another video. So in the last video I tried my best to get this solar panel working, and we did it using this charge controller, and it did not work out well at all. Now there is, I think, a very good reason for that, and I think, if I'm not mistaken, I saw this review on Amazon. It was by something in another language and I was able to translate it. I didn't realize this at the time, but basically you see these four different segments here: 5 volts, 6 volt, 9 volt and 12 volts. This is supposed to be marked off to tell you what input you can put into this. And so different types of these boards have different inputs, and for some reason they haven't marked it off here. So more than likely it's not a 12 volt solar charger. And so I was putting 12 volts into it, and that's probably what was causing issues. But at the same time, I mean, just this design here is not helpful. So one thing I might try and do is, for me to desolder these connectors and then solder them in. I mean, if you look, it is still a bit tight, isn't it? Look there, it's gonna still be tight to get the battery connected, because even though it says, okay, look, it's supposed to be 12 volts and maybe it could be 5 volts instead, I was still having issues with just connecting the battery in. Yeah. So anyways, what I did instead was I actually went and I bought a new solar charge controller, which can take 12 volts as an input and actually can output 3.5 volts. So this should be the perfect charge controller instead. It feels so much cheaper. So it's the Aliexpress up. I don't know what that is. Multi-chemistry battery charger with photovoltaic cell MPPT function, and they've highlighted that they're 12 volts. So I'm pretty sure I can put 12 volts into this. I was thinking that the output is does output 3.7 volts or something, but let me just quickly double check. So the output voltage, just reading from the specification, the output voltage is 1.2 volts to 11 volts. So apparently it's adjustable, and you've got that potentiometer there as well. So let me stick the 12 volts input here into the V in and then adjust this potentiometer. So if I, for example, take this here and just, I think you just spin it to the left a few times. Righty tighty, lefty loosey. Okay, so I think that's what you're supposed to do to get it set to the minimum. Now if I put the input voltage into here, I should test out and get one volt out on the right here. So that's the plan. Put 12 volts in here and then hopefully get 5 volts out on the right here, and then I can slowly twist the potentiometer up here until I get 4 volts or 5 volts out, and then I can charge this battery. So I think I'll go with 3.7 volts to see if we can get 3.7 volts out here. So yeah, let's see if we can do that now. Like I said, these things are getting exciting now, you know. We're kind of moving on from the theory side of things. I'm still going to do a lot of theory. Like, I want to understand, you know, what is this little circuit here? What are these ICs? I need to understand that, right? If I'm going to be designing this, I need to understand what's going on. So I'm going to do that, but I feel like this is the exciting part. I'm really enjoying this. So yeah, let's connect up the solar panel. Okay, so now what's the best way to approach this? We've got okay, I need to strip these wires a bit more. Maybe it might be best for me to just remove these wires, but okay, doesn't matter. For now we'll leave it there. So let's do some stripping again. I'm always a bit concerned, you know, that I'm going to run out of wire and then have a useless product. Okay. Alright, so I did it. I managed to solder it on, and I don't think I've caused any shorts. So there's a nice little bit of gap there. Alright, so they're not touching, so that's all good. So now what we need to do is, if we keep the panel like this, we just need to take our voltmeter and then just stick it in here on the other end and see what we get out. Nice, so it's above 0. Woohoo! Okay, so that's a good shout. So we're getting 17 millivolts. 17 millivolts, right? Yeah. Okay, so now if I take my screwdriver on my potentiometer and turn it up. Okay, it doesn't seem to be going anywhere. Nope, we're not getting a high voltage. Turn it the other way. Okay, it's increasing very slowly. Right, so I've come up with a decent strategy here now. So I've got the obviously solar panel connected here, and then I've just added 2 jumper cables onto the end here. So they shouldn't be touching at all there. Now this solar charger, I actually really like it. It's actually got a big hole there and then a small one. So I've just stuck it through the small one there. Okay, so now all we got to do is to make sure there's no short. Obviously I haven't got the battery connected right now. But if there was a short and I connect the battery, we're going to have problems, right? So, cool. So I've got my multimeter set to find the short. And if I just touch both of them, so battery and ground, then I don't get any beeping. So if I touch them both, beeping, beeping. And then no beeping, no beeping. Sorted. So we don't have a short there. So we now actually should be able to read the voltage from this output here, and a much easier way now is I can use alligator clips to just clip onto here like that and like that. Cool. And then same again here. So we got red is ground for some reason, don't know if I've done that. Ground and positive. Cool. Now I can flip my solar panel up and I can hold it up to the light. Okay, I'm still not getting anything. Kind of fluctuating a bit. 10 volts, 11 volts. Hey, there we go. Nice. Okay, so we got 11 volts back out of it. So let me adjust the potentiometer. I've just got cables dropping everywhere. Alright, so if I adjust this potentiometer, so we're at 11 volts right now. That was just off of that LED light that I showed you in the last video. So I turn it down by 1 full turn now. So let's see if we can get about 3 volts. What's that? That's still 22, right? 6 volts. 3 volts. It's fluctuating. Okay, so I think this is going to be a bit of a challenge. Interestingly, my LED on the board there is actually lighting up. Let me just it's a bit hard for me to show you on here. I've got another light here. Let me try this. Still only 20 milliamps. However, the red LED is lit up on the solar charger. So I'll just leave that light on there like that. We're getting 20 millivolts. Yeah, so I'm not getting any more. Just shut that out. No, it's not. If anything, it's dropping down. Okay, so it's turned on. So for whatever reason, the output is low. Okay, I think maybe what I might do, I'll show you 1 second. I might tape the solar panel just to this. Actually, to be honest with you, I might not even need to tape it because I don't know if this would work, but this actually has this diffuser on it. So I'm not sure if perhaps, oh dear. Okay, not sure if perhaps I could just take the diffuser off. Would the solar panel go in there? I don't know. Okay, let me try. Alright, so here's my current setup. We've got the solar panel taped to the light, and then the solar charge controller, which is bright at currently at 13.2 volts. So I'm just going to adjust the potentiometer on this and see what voltage we can get it down to. Just to get it down to 3.2 volts, which is brilliant. So what I'm going to do is I'm just going to increase it now. The red LED has gone off, but I'm going to increase it to 4.2 volts because according to Google, you should charge a 3.7 volt battery at 4.2 volts. So let's try and crank that up. There we go. I've got exactly 4.2 volts, which is perfect. So now I'm just going to connect the battery to it, leave the solar panel stuck up there for a while, and yeah, let's see how it goes. I'm just a bit concerned about heat. My light's probably going to heat up, and it is heating up. So yeah, we'll stick a battery in there. Alright, so there's good news and there's bad news. The good news is, you know, the light's on, the solar charger is still connected, and I've connected the battery. No explosions. All good so far. There's no lights on the solar charger. I don't know what's going on it. Yeah. So I think what I need to do is, I think I'm going to tape this solar panel. I'll tape it to my window that I've got over here, to my skylight. And as you can see, here in Britain, it is, how'd you put it? Dark and cloudy. So I'll test the battery voltage of this now, of this battery, and then we'll tape the solar panel to the window and come back later on today and check the voltage. Hopefully we got more. That's the hope. Alright, so I tested the voltage and I got 3.91. Let's see if I can replicate that whilst I'm recording. Let's hold that down. There you go, 3.91 volts. So another good news is, I'll show you. You can look outside, it's currently 7 AM, so the sun hasn't risen yet. However, the good news is that my charge controller, the LED on it, if I can focus, there you go. There we go. There you go, the LED is red, it's lit up. And there's not even anything connected to it. I'm not really sure what this means, but the LED is flashing now. I just have a voltmeter or a multimeter attached to it, and it's reading 7.5 millivolts. So I'm not sure what that's all about, but I'm just going to attach the battery anyways. We had 3.916 volts, so attach that battery and then just see what we get by the end of the day. So I've connected the battery, and I'm actually thinking now, I added the battery and the LED is way brighter. So I'm thinking we may be getting some leakage voltage that's actually powering the solar charge controller. Oh yeah, I don't know. Is that, it must be the case, right? Probably. I could test it by trying to stick a diode in there. Let's try. I did actually put this diode there, and then I realized when I disconnected the positive supply of the battery, the charge controller is still blinking. So yeah, it's not being supplied any power by the battery. So let's just connect that back. And again, we shall just wait. You know, let the sun come out, yeah, and charge our battery, hopefully. Alright, so it's been about an hour now, and the sun's slowly starting to rise. So what I'm going to do is I'm just going to check the voltage here at the solar panel, and then also here going into the battery. So let's just check. So first up, we've got the input voltage coming in from the solar panel, and the output voltage, the input voltage, which is 11.96. Nice. So we're getting a nice 12 volts in this. And then now into the battery. Ooh, 3.915 volts. Nice. Okay, so let's just disconnect the battery and see. Like I said, it's only been an hour, so I'm not expecting anything. But it's possible. Maybe. 3.914. We've actually gone down a bit. Okay, interesting. Well, let's just carry on and leave it. But so far, it looks like the panel was doing its job. Again, what's interesting is that actually, so I've disconnected the battery. The voltage, I set it at 4.2 volts. Now, however, that was when it was connected to my light. And so this panel is probably not, you know, that when it was connected to my light, that was probably getting 13.5 volts. Oh no, actually, no, look at that. All right, I'm wrong. So it's 4.2 volts right now at the output going into the battery. But yeah, the battery's still only 3.9. It hasn't charged at all. So we'll see. If it doesn't go up at all, then I'm guessing it might need a higher voltage. I don't know. So yeah, we'll see about that. Let's just connect this back again. Oh, I've kind of given myself electric shock there. Interestingly, I felt like a bit of a shock up here. I don't know why. Anyways, yeah, so we'll see what it's like still later on today, once the sun's fully come out, and you know, maybe around midday we'll check it. So we got some bad news. The solar panel is there. It fell off the window. I taped it with 3 different bits of tape, so not sure what happened, but let's just test the voltage. I've left it for about 9 hours. I don't know when it fell off though, so I don't know how long it was up there for, but we got 4.05 volts. It feels good. We got it working, people. So literally solar panel with this charge controller, and we got it working. So I've actually also bought another solar panel, a smaller one, because I thought, you know what, maybe 12 volts might be the problem here. So I'm going to try and use a smaller 5-volt panel in my next video, and we'll try and see if we can get some of the other charge controllers working. But this one's great. Look, it's actually still lighting up right now, and it's not even facing the window at all, and there's no other windows in this room. So this is really good. I'm actually really excited. I'm so happy that I managed to get this to work. I'm not sure if I'm going to be able to power a Raspberry Pi with this small battery. I may need to get a larger battery, I'm not sure. But obviously, in terms of shipping the kit, you want to ideally not include a battery and just get the people to use their own rechargeable batteries. But then that's an expense for them, right? So yeah, I'm probably gonna have to ship the final product with a battery, of course. But yeah, we're very happy with that 4.05 volts. So in the next video, we'll test out a smaller solar panel with a different charge controller, maybe even the same. What's the input of this solar charge controller? Let's check. Actually, the input voltage is 12 to 28 volts, as you can see there. So 12 to 28 volts there. What was just surprised me was that I actually only paid £3.09 for this charge controller, which is amazing. So yeah, I think what we'll do is in the next video, I'll test it out with the smaller 5-volt panel, which I've got in here, and then I'm going to try out some of those other charge controllers, see if I can get them working. If we can get all of the charge controllers working, that would be ideal. Maybe even this one that I blew up. If we can get all of them working, that would be perfect. And then after that, what I want to do is I've got a Great Scott video where he explains how, I think he actually uses this exact charge controller as well, where he basically explains, maybe actually, you know what, I could even repair it. If there's an IC burnt out or a resistor, I actually could try and repair it, which would be a good learning experience as well. But I want to watch his video, go through it on a video of mine, and basically study the video in depth to the point that I understand everything. And then I actually want to look at the circuitry involved in these charge controllers. So that's what we're going to do in the next few videos. Once I've got charge controllers down, sorted, I understand them, I know how they work, then I'm going to move on to improving this actual kit. So right now we've got, look, just the solar panel, the charge controller, and a battery, right? So next up we want to add an AC output, and we also want to add a DC output. But we want to add, instead of having a DC output from the charge controller, we want to have a DC output from the battery itself, which that's a bit complicated. I have no idea how I'm going to do that. But again, yeah, this is a great learning experience. So yeah, that's it for this video. If you enjoy it, leave a like. I'm learning a bunch. I hope you guys are. 4.05 volts. Get in there.